Welcome back to differential calculus class. So we are still on rules of differentiation. So in this class, I'll be teaching you the rule of natural logarithmic function. So given f of x equals ln a particular function. So this ln is the natural log sine. So we have a function. This function could be a linear function or power function. So if you are to find the y dx, that is the derivative of this, which is f prime of x, the rule says that we are to find the reciprocal. Say, the rule says the derivative of this function is the reciprocal of the function, the relevant function, which is that is 1 over this. Different the derivative of the function itself, that is multiplied by u prime x. So in other words, given f of x equals ln, that is the natural log of a function u of x, the derivative of this function is equal to the reciprocal of this function, that is the 1, that is 1 over u of x multiplied by the derivative of the function itself. So now let's take a look at some examples. Let's say we are asked to find the derivative of, let's say we have 1. The first question here, let's say we have ln what? 2x, x raised to the power 3. B, we have ln, we have 1 plus x. Okay, let's take another one. See, let's say we have 2 ln x squared, as the case may be. So let's apply this rule. Solution. For the first one, A, we have this. Okay, this is f of x anyway. So if I say the derivative of this, I have, for the first one, I have, let me say this, f of x equals ln 2x raised to power 3. Okay, don't forget there's let's put it there so that you avoid confusion. F of x. So let's put f of x here. You can also put y if you like. And likewise b, let's put f of x. So it's not compulsory to put it, but we are just doing it to avoid confusion. So b is it. Now f prime of x is equals to this. The rule says the derivative of this function is the reciprocal of the original function of the function here, which is u of x. The u of x here is simply 2x raised to the power 3. Anything apart from ln here. So we have 1 over 2x raised to the power 3. Okay, then multiply by the derivative of this u. Okay, that's the derivative of this u function. So that is, we are going to find the derivative of this. Okay, in essence, let me show it clearly. So if we know that this prime of x, this f prime of x is equal to 1 over u of x, then we say multiply by this. So here we know that u of x here is simply 2x raised to the power 3. Okay, it's simply 2x raised to the power 3. Then we know that u prime of x is simply the fraction of this. So we differentiate this power function, we bring down the power. That's 3 times 2, that will be 6. Then we have x raised to the power 3 minus 1, that is 2. So we can now go back. So then we have f of x is equal to 1 over u of x. That is 1 over u of x is equal to 2x raised to the power 3. Then multiply by derivative, which is 6x raised to the power 2. Then we multiply this. This gives these two. We have 2 here, 1, 2 here, 3. Okay. So we know that here we now have x raised to the power 3, this x raised to the power 2. We apply the law of indices. Okay. So here we are left with 1 over x. So the answer is 1 over x. Okay. Now, for the second one, so I'm going to clean this to do it because of space. Okay. Okay, let me do it here. Anyway, let me do it here. Let me do it here. So for the second one, B, so we have f of x equals ln, then we have 1 plus x, ln f plus x. Okay. Now, you remember the rule says that f of x, we have this, is equal to the reciprocal of the original function. This is u. Then multiply by the derivative of the function, which is 1 plus x. Okay, let me just x here. Okay, and you know that here from this question, your u of x is equivalent to 1 plus x. If this is so, then we have the u prime of x, that differential of this with respect to x. This is a linear function. So the equation of the relevant variable, it gives the derivative of that linear function. Because suppose the coefficient of this x here, it is 1. So here we have 1. In other words, we now have our f of x here is now equals to 1 over u of x. Whether u of x is 1 plus x, then multiply by the derivative of this u. So the derivative of u is 1. So multiply by 1. So in other words, our final is now 1 over 1 plus x, which is our final answer. Okay. Now, for the last one, for the last one, see, the rule says that f of x is equal to 1 over u of x, then multiply by u of x, u prime of x, that is the derivative of the function. So here, you know that u of x, even u of x equals to x squared. Anyway, then you know if this is so then we have u prime of x is equals to, you differentiate this, so you bring out the power 2 times 1 here, you have 2, then we have x. 2 minus 1 is 1, so you don't need to write it there. So now let's apply that. So therefore f of x here, f prime of x here is, don't forget you have a constant before. So this constant, just put it outside. Then deal with the function, the other component of the function itself. So we have 1 over u of x, which is, our u of x is x squared. Okay? Then multiply, we have the derivative of u of x, we have 2x. Okay? So therefore here we have 2 bracket 2x divided by x squared. Okay, so you can see that this, you have x here, you have x squared here. So 2 times 2 inside here, you have 4. Then you have this x will go away and it remains 1 x here. So in other words, we have 4 over x, which is our final answer. Okay. So can you try this? So let's say we have y equals ln x squared plus 5. This is 1, 2. Y equals 4 ln